Hello everyone, in this video we are going to learn about inequalities on graphs. We will meet multiple graphs of functions when we want to find the solution to inequalities. What we need to do, we use a graph to solve that. For inequality fx less than gx, we need to find the values of x for which y equals to fx is below y equals to gx. And for inequality fx greater than gx, we need to find the values of x for which y equals to fx is above y equals to gx. Let us see some examples. So the first one, we have two linear functions. L1 has equation 3y plus 2x equals to 8, and L2 has equation x plus y equals to 3. In the part A, it asks you to find the coordinates of the point of intersection from the sketch. So we have the sketch over here. We have the green one is L1, and the blue one is L2. So we need to find the intersection point. We can see that is over here, which is x equals to 1 and y equals to 2. That is 1, 2. So for the part A, what do we get? We get 1, 2. And then in the part B, it asks you to write down the solution to the inequalities 3y plus 2x greater than x plus y. We can see that 3y plus 2x is linear 1. Here is linear 1, and x plus y is linear 2. And you need to find the linear 1 greater than linear 2. So what do we need to do? We need to find the values of x for which here, so here, yet. So for which L1 is above L2. So find the values of x for which L1 is above L2. So we can see where is the L1 above L2. So what I see L1, so from here, start from here, L1 is below L2. Then when you see go along, and we find that here we have changed that L1 now become L1 now is above L2. So is when x greater than 1. Right? So we can see that from this part is L2, right, that L1 is below L2. And from this part is L1 is above L2. So here the left hand side is L1 less than L2, and the right hand side is L1 greater than L2. Yeah, that's for two linear functions. And let us see the second example. Is one is linear and another one is quadratic. So for fx, we have y equals to x plus 2. This is linear. And for the gx, that is, I read it wrong. Gx equals to x squared. Yeah, that is correct. So we have gx equals to x squared. That is quadratic. And for part A, it asks you to find the coordinates of the points of intersection. So we have the sketch that f and g. So the red one, let me change the color. The red one is fx, and the orange one is gx. And then you need to find the intersection point. We can see here are two intersection points. The first one is over here. Here is -1 and 1, so it's -1, 1. Another intersection point is over here. That is 2, 4. So 2, 4. Now, we need to write that. So intersection point, -1, 1, and 2, 4. For the part B, it asks you to write down the solution to the inequality x plus 2 greater than x squared, which means you need to find x plus 2 greater than x squared, which means you need to find the values of x for which, so x plus 2, that is linear, that is fx, so greater than is above gx, so x squared. So which part satisfies that? So fx above, so the right line above the orange line. So from here, we can see the first intersection point. Let's see that on the left-hand side, we see that the orange one is above the right one. So in here is the orange one, so gx greater than fx. And from the right-hand side, we can see that the right line is above the orange line. So that is fx greater than gx. And we can see from the second intersection on the left hand side, so it's fx greater than gx. And on the right hand side, we can see that is orange line, now it's above the right line, so it's gx greater than fx. In this case, we can find the value of x is between x, that is less than 2, and greater than -1. So it's from here to here, right? So that is the answer. Now let's move on to the third question. So we have two quadratic functions. The first one, fx equals to x squared minus 4x minus 5. And the second one, gx equals to 6 plus 5x minus x squared. It asks you to find the set of values of x for which fx less than gx. Well, in here, the question does not provide the sketch of the graphs. So what we need to do, we need to do the sketch at first. So what we have y-axis, x-axis, and the origin. And for the fx, a equals to 1, that's greater than 0, so it has a small face. And we want to find the where does the function fx crosses x-axis and the y-axis. So when y equals to 0, what we have x squared minus 4x minus 5 equals to 0, implies that x minus 5 times x plus 1 equals to 0, which implies that x equals to 5 or x equals to minus 1. So it intersects, so it crosses x-axis at 5 and minus 1. Maybe 5 over here and minus 1 over here. And when x equals to 0, what do we have? We have y equals to minus 5. So it crosses 0, minus 5, maybe here minus 5. We have a sketch of the fx, which looks like, sorry, terrible drawing. Oh my god, please be smooth. I hate my drawing. Please, smooth, 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 smooth. Yeah, kind of smooth. And then what we need to do, we need to sketch the gx. Gx, we have a equals to minus 1, so coefficient of x squared that is less than 0, so it's a set face. And also similar way, when y equals to 0, what we have 6 plus 5x minus x squared equals to 0. Implies that minus x minus 1 times x minus 6 equals to 0. This we have x equals to minus 1 or x equals to 6. And when x equals to 0, y equals to 6. So we have maybe, let this be longer. Maybe here is 6 and y also be longer. So y over here and maybe 6 is here. And also minus 1. So we have the, now we can sketch gx. So pass here, and pass here. Maybe look like that. Sorry for terrible drawing, use the iPad, it's so hard to do that. Sorry for that. And then we find there are two intersection points. The first one is over here, and the second one is over here. Now what we need to do, we need to find the intersection point, which means we need to find the value of x for which fx equals to gx. Now let's do that. So fx is x squared minus 4x minus 5 equals to 6 plus 5x minus x squared. And then we rearrange that. What we have 2x squared minus 4x minus 5x minus 5 minus 6 equals to 0. Implies that 2x squared minus 9x minus 11 equals to 0. What we have 2x minus 11 times x plus 1 equals to 0. Which means you have 2x equals to 11, x equals to 11 over 2, or x equals to minus 1. So in here we find that the two intersection points, one is at x equals to minus 1, and here is x equals to 11 over 2. To do the inequality, to solve the inequalities, we usually only find the x coordinates. It's not so important to find the y coordinates. Now, the question asks you to find fx less than gx. So fx less than gx, what does it mean? You need to find the values of x for which fx is below gx. Now let's see the graph. So the small face is fx. This is my mistake. You need to write down the function next to the curve at the beginning, so you know which curve is which function. And the set face is the gx. So here's the gx. fx is below gx. So let's go through the fx. So from here, we see that fx is above gx, and it starts at x equals to -1. Now fx is is below gx, and then go through, see, still below the gx. And over here, the second intersection point, it has changed that fx, then fx is above gx. So the purple one, or maybe the pink one, I'm not really sure what color of that. So what we have that the purple one, so it's x between 11/2 and -1. So x less than 11/2 and greater than -1. That is a part, and that is the answer. Here is a summary for this lesson. Hope you enjoy it. You can pause the video and make some notes. Thank you.